everyone, welcome to my channel. I'm Leo. Today let's do some more Leetcode problems. This one is called edit distance. Let's read the prompt. So this edit distance is usually used in string matching or auto-completion like Microsoft Word. So let's read the prompt. Given two strings, word 1 and word 2, return the minimum number of operations required to convert word 1 to word 2. So we are allowed to have the following three operations. One is to insert a character, the other one is to delete a character, or to replace a character. Let's take a look at the example. The first one is horse, the second word is Ross, and the minimum number of operations to convert word 1 to word 2 is 3. So the first thing is to replace H with an R. Then we can remove this R and it became Rose. Then we effectively remove the E at the back. Then we got our target word Ross. Okay, same thing happens for this as well. Okay, so how do we do this problem? This is a minimum number of operations to convert word 1 to word 2. The most intuitive thing in mind is to generate all the path required to convert word 1 to word 2 and then calculate the minimum number of operations needed. Okay, so that's a recursive solution. And I think it'd be more effective to use a dynamic programming because we have an overlapping subproblem here. So to know how many minimum number of operations to convert horse to Ross, I think that's one operation away from turning horse to Ross. Okay. So there's a substructure here. Let's see. So there are three operations needed. First, there will be some scenarios here. So first, if the characters are the same. In this case, like if we have HORSE to HOSE, the first character and the first character of the second word are the same. In this case, we can just action like this. Like we ignore the H. We go one step back to the previous character and do the matching next. Okay, so that's one way to view it. And the second thing is if the characters are not the same, different. Okay, we have three operations, remember. So the first thing is to insert. Excuse me. If we insert something here, like word 1, we're going to use horse, and word 2, we have Ross. Suppose we're here at the first word, at the first letter. Okay. If we insert an R here, at this time, this R and this R in the second word will be the same. So we don't have to compare it at all. It's effectively equal to comparing H with an empty string here. Okay, so this insert will be 1 plus this one is the insert operation, plus if we have a DP table, it will be word1 index, which remains the same, and word2 index minus 1. Okay, so that's insert. And the second operation we have is to delete. As you can see, word1 is still horse, and word2 is still Ross. And we still have this I here and J here. If we delete something from the first one, we have to start over from the empty string to make the matching. So in this case, the total operation we need is to word1 index minus 1 and word2 index. Okay? And remember, we have a third operation, which is replace. So still, we have word1 as horse. Okay. And we also have the I here, and also word2, we have Ross, and J here, okay? So if we replace this with R, it equals to, we only compare the rest, okay? So in this case, the total operation we need is word1 index minus 1 and word2 index minus 1, okay? So if they're the same, we can say we don't have to do anything. We can just use word1 index minus 1, word2 index minus 1, okay? We don't have to do anything. Okay, so that looks like our solution. So let's code it out. First, I'm gonna record their length separately. Word2.length, okay? So let's consider some base cases. So if word1 equals to null, or an empty string, we will return w2 len because we're going to insert every character in word2, okay? Also, if excuse me, if word2 equals to 0, it's an empty string, we have to delete every character from word1 to match it, okay? So we'll return w1 length, okay? And if now they have some length, they're not empty strings, so we're going to use a DP table to record everything, okay? We will need to +1 because we're going to add an empty string there, okay? So for this, I think we can use the table to do something like this. So first, we're gonna have an empty string. Okay, let me do this. Okay, so first we'll have an empty string, and then we will have R, O, S, and here we're also going to have some empty string, and we have H, O, R, S, E, okay? So the first column would be 0 because we're matching an empty string to an empty string, okay? And if we're going to match an empty string to an R, the minimum number of operations we need is 1. We're only going to add 1 R there, and this is 2, this will be 3, and also this one will also be 1, 2, 3, 4, Okay, so we're going to fill out the DP table with the base case. So for int w1 index equals to 1, w1 index is less than w1 length, w1 index plus plus. So the dp w1 index 0 will be equal to w1 index. Okay, yeah, like that. And also for in w2 index equals to 1, w2 index less than or equal to w2 dot length, w2 index plus plus. Our dp0 w2 index will equal to w2 index. Okay, so we filled these out. Now we can start filling the table from 1, 1, okay? So for w1 to 1, w1 index less than or equal to w1, w1 index plus plus, and I think I can copy it from here. Okay, if there are four situations here. So if the characters are the same, if the word 1 dot character at w1 index minus 1 equals to word 2 dot character at w2 index minus 1. In this case, w1 the dp should be the same as w1 index minus 1, w2 index minus 1, okay? Else, we are going to get the minimum of all these three operations, okay? So dp w1 index w2 index equals to math.mean w1 index minus 1, w2 index, dp w1 index, w2 index minus 1, and dp w1 index minus 1, w2 index minus 1, okay? And don't forget to add one operation because it was different. So we have to do something, perform the operation there. Okay? So what we're going to return is the last element on the bottom right corner. Okay? So we're going to return dpw1 length and w2 length. Okay, so 1, 2, 3, 1, 2, 3, 4, 5. We're effectively at the bottom here. Okay, that should be all right. Let's take a look. Okay, it tested all fine, and I will submit it. Okay, I think it's accepted. All right, thank you so much for watching. I'll see you in our next video.